Hello guys, welcome to our class for today. So we are looking at, for our class for today, we'll be discussing heat energy and expansivity. We have introduced heat energy. We've talked about temperature, measurement of temperature, conversion of temperature from one scale to the other. And then now we're looking at heat energy and expansivity. So in this particular class, we'll be talking about linear expansivity, and then application of expansion. Then we'll look at the equation for linear expansivity. Then we'll now solve some problems, some calculations on linear expansivity. So please, if you are ready for the class, have you gotten your writing materials, your calculators and everything? If you are ready for the class, then we'll go through the class. But before then, if you have not subscribed to this channel, or if you have visited this channel for the very first time, please subscribe to this channel. In this particular channel, we are teaching you physics. We bring physics direct to your home. So we are not just solving problems, but we are following the Nigeria curriculum for senior secondary school physics. So if you follow all our lectures from the beginning, you will see that we are following the curriculum step by step. Okay, this is work in progress. We are still working on it and we are progressing gradually. So just follow us from the beginning, whether you are in SS1, you are in SS2, you are in SS3, you are preparing for JAM examination, GCE, WAEC, or any of these foreign examinations. Whatever knowledge you gain here will be of utmost benefit to you. Is that okay? So please subscribe to our channel, give us a like, give us a thumbs up, click on the notification button so that whenever we upload a new video, YouTube will notify you. That's okay. Also invite your friends to come and join this channel, right? So you can reach us through the WhatsApp number that's showing on your screen. And this is No Man Science Tutors Online. I remain Otto Michael, so you are welcome to our class for today. And we are moving straight now to our lecture for today: heat energy and expansivity. So let's go. So for heat energy, we talked about heat energy in our previous class. So in this particular class, expansion is one of the effects of heat energy. That okay? Expansion is one of the effects of heat energy. It's not only expansion. Heat energy can cause so many other effects. Like heat energy causes change in temperature, right? Because as you introduce heat to a body, the temperature of the body will begin to change. Okay, it also leads to change of state of a body. Okay, when you introduce heat to a body, it can cause a solid to melt. So it can actually lead to change of state. It can cause expansion of a body. It can also change the physical properties of a body, like the electrical resistance, electrical conductivity, elasticity of material, density and color of some liquid or substances. Heat can cause a change in all these physical properties of some substances. It can also lead to thermionic emission, that is emission of electron when the metal is heated. Okay, then it can also lead to chemical change. So as the case may be, heat can cause any of these effects. So these are some of the effects of heat energy, and I want you to take note of all this. Is that okay? So having known some of the effects of heat energy, we'll now be looking at expansivity or expansion. So what is expansivity or expansion? Expansivity and linear expansion. Expansion simply means increase in size or volume of a substance as a result of application of heat. So application of heat actually causes expansion. Now, most of these concepts that we discuss, they have kinetic molecular theory explanation for them. Like for expansion, what is the kinetic molecular theory explanation of expansion? Okay, so according to the kinetic molecular theory, when an object is heated, just imagine that you are heating an object. Is that okay? Because for you to actually understand the kinetic molecular theory of an object, of a particular phenomena, right? You need to like visualize what is happening. If you can visualize it, it will make it easy for you to understand, because most of this concept expansion, we'll talk about expansion, increase in temperature, uh, you talk about maybe conduction and all that. They have kinetic molecular theory explanation for this concept of phenomena. So you need to like visualize what is happening so that you can be able to understand it easily. So when heat is actually introduced to an object, okay, the molecules will begin to acquire kinetic energy, right? Why kinetic energy? Because the velocity, as you are introducing it to the object, the velocity of the molecules of the object will begin to increase. And as the velocity is increasing, the kinetic energy of the molecules will also increase. And as this is happening, it will begin to make the molecules to vibrate, right? It will begin to vibrate. The molecules will begin to vibrate about their mean position. The more heat that is applied, the more the vibration or displacement of the molecules about their mean position. And as such, the average distance between molecules becomes larger, and this will now lead to the increase in size and expansion. So if you can visualize it, you just understand that okay, when an object is heated, the molecules will acquire kinetic energy because of increase in the velocity of the molecules of the body, and this will just increase the vibration of the molecules, and then the displacement about their mean position will also increase. And as a result, the distance between the molecules will become larger, and that will lead to increase in size and expansion. Okay, so that is the molecular theory explanation of expansion. So what are some of the advantages of expansion? Expansion is used in the thermostat to maintain steady temperature. Okay, like in your electric iron, you know that if you are used to iron, when you put on the iron, after a time the iron will switch off. It will come up again when it gets cold, just like that. So it is used to maintain a steady temperature. It is used in riveting of two metal plates, like in railway construction or construction of bridges. It is also advantage of the construction of automatic fire alarms, just like in this electric iron. Fitting of metal wheels on rims. Yeah, if you want to fit a metal wheel on a rim, you need to hit the metal wheel first before you fit it into the rim. The removal of tight glass topper. Okay, so these are some of the advantages of expansion. What about the disadvantages? Expansion causes deformation to bridge structure fixed at both ends. So if they construct a bridge and the two ends are fixed, expansion can cause deformation of the bridge structure. So what they do normally is that one of the end of the bridge is fixed while the other end is put on rollers. Then if you look at the bridge, there are some gaps. Those gaps, they are called expansion gaps, so that there won't be deformation of the bridge structure. It causes a thick glass tumbler to crack, break when hot liquid is poured into it. Now, this can come to you as a question that why does glass tumbler break or crack when hot water is poured into it? And why this happens is because of uneven expansion between the inner layer of the glass and the outer layer. So this uneven expansion will make the inner layer of the glass to expand more than the outer layer, because glass is a poor conductor. And because the inner layer will expand more than the outer layer, it will now make the glass to crack. So for you to prevent this, you can put a metal spoon inside the glass. The metal spoon is a very good conductor. So as you are pouring the water, the metal spoon will just conduct the heat away. So your glass cup will be safe. So you can use this to actually protect your glass cup from getting cracked if you have this simple knowledge of physics. Is that okay? It causes railway lines laid without gaps to buckle, affects oscillation of the pendulum clock and the balance wheel. So these are some of the disadvantages of expansion. Okay, So, but in what area do we apply expansion? So that's what we'll look at now. Application of expansion. In what area do we apply expansion? Okay, areas of application of expansion, we just discussed them now when we talked about advantages of expansion. So expansion is used in the construction of bridges and buildings. It is also applied in the gaps in railway lines, in the installation of telegraphic lines and metal wires. You know, telegraphic lines or metal wires, when they are too tight, when they are too tight, it can make them to sag. So what is done normally is that there is a gap that allows for expansion. Okay, there's an allowance that is given so that it can take care of expansion. It's also used in the bimetallic strip, and the bimetallic strip is used for to control or to maintain the temperature, like what we just said about the electric iron. Now, this picture just depicts what the bimetallic strip looks like. The bimetallic strip is a strip of two metals that has um, different expansivity. So bimetallic strip consists of strip of two metals such as iron and brass attached rigidly together side by side. The strip is used to maintain a steady temperature, hence it is used as thermostat. When heated, the strip will bend because different metals expand differently. So for the iron and brass metallic strip, when heated, the brass expands more because it has higher expansivity than iron. Hence, it will be on the outside. When cool, the iron will be on the outside. So what this statement simply means is that because brass expands more than iron, when the strip is heated, the brass will be on the outside, while the iron will be on the inside. Then when it is cooled, the iron will be outside and the brass will be inside. Now, this bimetallic strip is what is used to control the temperature in fridges, in refrigerators, in conditioners, and in the electric iron. So if you look at it, when an electric iron has worked for some time, it will trip off. The same thing happens in fridges, the same thing happens in air conditioners. What is causing that tripping off and tripping on is the bimetallic strip. When the bimetallic strip is cool, it will straighten up and make contact. That okay, it will make contact. Then as it is getting hot, it will start to bend away from the contact, and once it bends away totally, the equipment will trip off. Then when it cools back again, it will make contact, and then the equipment will peak again and it will continue to work. So that is how the bimetallic strip works. So the bimetallic strip is applied in the balance wheel of clocks and watches, in bimetallic strip thermometer, thermostat of electric iron, and electric fire alarm. These are the areas where the bimetallic strip is applied. I hope this is clear. Okay, so if you understand this, we are going to look at equations of linear expansivity. Equation of linear expansivity. Now, linear expansivity of a substance is defined as the increase in length per unit length per degree rise in temperature. The unit of linear expansivity is per Kelvin or per degree centigrade. Now, what this statement simply means that the linear expansivity is the increase in length, that is increase in length, which is the expansion, all over original length times increase in temperature. So this is basically the equation for linear expansivity. This is the equation for linear expansivity. Now, all these statements, they can be written down in a different form. Okay, so if LO represent initial length of a metal or of a material, and 1 represent the final length of the material. It means that the change in length, or the increase in length, or the expansion is equals to expansion, or increase in length will be equals to the final length minus the original length. Now, if theta 1 is the initial temperature and theta 2 is the final temperature, then increase in temperature or change in temperature is equals to theta 2 minus theta 1. Original length is equals to LO. That's what we have said. Original length is equals to LO. That okay? So if you put all this into this statement above, we have that as linear expansivity is equals to expansion, which is L1 over LO all over original length multiplied by change in temperature, which is theta 2 minus theta 1. Okay, so once you have this, you can derive any of these other equations. So this one, you can also write it as expansion all over original length times change in temperature. Is that okay? So depending on the equation that you are given, you can actually apply them differently. Okay, so if we write this equation, we can write this equation to be this equation. We can also write this as L1 minus LO is equals to the linear expansivity times original length times temperature change. Okay, so with this equation now we can find the expansion of a particular material. Can find the expansion because L1 minus LO is equals to expansion. So we can actually use this equation to find the expansion. Then in some instances, if you are asked to find the final length, which is this, you can just write your equation that final length is equals to LO plus expansivity, linear expansivity times that. So you can write this equation to look like this: 1 plus expansivity times temperature change. So with this equation, you can actually find the new length of a particular material, as the case may be. So depending on what you are asked to find, you can actually use, what I have written here now is what I just wrote here too. These are what I have here already. So, okay, sorry. These are what I have here already. Is that okay? So you can apply any of this equation to solve whatever problem you have on linear expansivity. Okay, so we are going to go straight and solve some problems just to drive on this point that we have discussed so far. So this is a sample question. A copper rod whose length at 30 degrees 10.0 meters is heated to 50 degrees centigrade. Find the new length of the rod. Take linear expansivity of iron as this is supposed to be copper, right? Yeah, that is supposed to be copper, not iron, because we're talking about a copper rod, so this is supposed to be copper. So sorry for that mix-up. It's typographical error. That is a typo error, so just sorry about that. Okay, so this is supposed to be for copper and not for iron. Since we are talking about a copper rod, so this should also be for copper and not for iron. Is that okay? So a copper rod whose length at 30 degrees temperature is heated to 50 degrees centigrade. Find the new length of the rod. Take linear expansivity of copper as 0.0017 per Kelvin. 0.0017 per Kelvin. Okay, so what we can do first of all is just write the equation down. Linear expansivity is equals to final length minus original length all over original length multiplied by change in temperature. Okay, is change in temperature. Fine. So this is the equation. So let's bring out this each of these variables now. From here, from what is given to us, L1 is what we are looking for because it said find the final length. So L0 initial length is given to you to be 10.0 meters. Okay, then initial temperature is given to you to be 30 degrees, and final temperature is given to you to be what? 50 degrees. So 30 degrees centigrade, 50 degrees centigrade. So which means change in temperature is equals to 50 minus 30. So that gives us 20 degrees centigrade. Okay, so this is our change in temperature. Now we are also given the linear expansivity of the metal to be 0.000017 per Kelvin. So these are what are be given to us. Now from the equation that we wrote before now, we said that expansion is equals to what? Expansion is equals to what? It's equals to original length multiplied by linear expansivity times change in temperature. That was what we said, and we now say that final length is equals to original length 1 plus expansivity times change in temperature. So I haven't gotten this equation. Substitute into this equation all that you have here. So this will give us 10, 1 plus the expansivity 17 times 10 raised to power minus 6 times 20. Okay, so this is what you have. By the time you work this out, you will now have 10 you have 10. When you work this out with your calculator, when you work that out with your calculator, you're going to have 10.0034 meters as the new length of the materials of the material, I mean of the copper. This will be the new length of the copper. So guys, this is how to apply that equation. Let's do one more. This is another sample question. This question says a metal of length 15.01 meter is heated until its temperature rises by 60 degrees centigrade. If its new length is this, calculate its linear expansivity. So from this equation, linear expansivity is equals to new length minus original length all over original length multiplied by change in temperature. So here you are giving original length is given to you to be what? To be 15.01 meters. New length is given to you to be 15.05 meters. Change in temperature is given to you to be equals to 60 degrees centigrade. Okay, so I haven't known that you are asked to find linear expansivity. Linear expansivity is unknown. Okay, so this is what you have. So just substitute into this equation, you have linear expansivity is equals to 15.05 minus 15.01 all over 15.01 multiplied by 60, which is the change in temperature. Okay, so guys, if you work this one out, you are going to have that the linear expansivity is equals to 0.0004 per K. Is that okay? So this is what you have. So work that out and then you see your answer. So I think this thing is easy. If you follow through, please, any area that you don't understand, you can play the video back. Okay, but I think this should be simple. But if you don't understand, play the video back. Play the video back. You get better understanding. Is that okay? So you have more questions to solve for yourself. Please try and solve this question. Try and solve this question. Then, if you have any challenge, you can reach me through the WhatsApp number that will be showing on your screen. So this is where we are stopping our class for today. Thank you so much. But before then, if you have not subscribed, what are you waiting for? Please, if you like what we are doing, subscribe to this channel, give us a like, give us a thumbs up, place your comment on the comment section, invite your friends to come and enjoy what you are enjoying here. Also, click on the notification bell so that when we upload a new video, YouTube will notify you. This is Normal Science to Source Online, and we thank you so much for your time. We hope to see you in our next class. Please also reach us through the WhatsApp number that is showing on your screen. Is that okay? Thank you so much. Please invite your friends to come and enjoy this wonderful class that you are also enjoying. Thanks. See you in our next class.